So I'll explain what are the things we'll start with this initial session, and then we will gradually progress on towards the hands-on and show you the different tools and technologies that we have in Azure to work with the data engineering profile. Now, since we're pretty new to Azure, before we start with the hands-on and give you more background about the data engineering, let me actually talk a little bit about the cloud computing environment. So when we look into the cloud computing, what is cloud computing essentially? So simply put, if you think from a very holistic perspective, cloud computing is a space which is nothing but a portal. So if you're working in Azure, if you're working in AWS, that is Amazon Web Services, or if you're working in Google Cloud Platform or GCP, these are the three major CSPs. We call them CSP, nothing but cloud service providers. They have a portal where essentially you log in and you start your development. So couple of advantages that comes with any cloud service provider is that you don't need an initial cost. So you don't need to own any hardware. You don't need to set up any software. There are no licensing costs involved. You can start with day one. And also there is no initial capital expenses, because you don't need to buy any hardware. You can just rent it and you can start with a pay-as-you-go model. Now, a couple of important terminologies or concept we should remember in the cloud computing environment whenever we're working. So if you look into the cloud model, how do we set up our environment? There are essentially three models that we have in the cloud computing. The first is called as a public cloud, then we have the private cloud, and then we have the hybrid cloud. Now, how do they differ? Public cloud, which is the most common thing that you're going to use, is something like this, where if you buy a service from any of the CSP, since we are focusing on Azure, I'll take most of the examples from Azure. Let's think of an example that I want to create a SQL database on Azure. So think of it from an on-premises perspective. Whenever we create a SQL server, I need to buy a hardware. So I need a physical machine where I will have processor, I will have RAM, I'll have hard disk, and I'll have SQL server. So I need to buy the license of SQL server and install it. So I need to get so many costs beforehand. In case of Azure, when I create an Azure SQL database, I just log into the Azure portal. I quickly create my configuration and I create a SQL database. Now, when this gets created, Microsoft, being a CSP, has to create this physical SQL server in some of their data centers. So Microsoft, being a very large organization, they have currently around 32 data centers around the world, if I'm not wrong, and it's increasing every day. So they create a data set, they create an instance of your SQL database in one of their physical data center that you can choose where you want to host this physical database. Now, when they created the hardware where this physical SQL server is created, you as a customer don't own that hardware. So this hardware is essentially shared across multiple vendors. So think of it like this. If I am a user who's creating a SQL database in, let's say, that East US region, there is one more user who's creating another SQL database in East US region. Microsoft might create this SQL server or this physical database in the same hardware rack, but do not worry. The data is never shared across the vendors. It's only the hardware which is shared across the vendors. So here the cost obviously becomes less because you are essentially sharing the hardware between vendors. So this is a concept of public cloud where the hardware is shared across multiple vendors. Then we have the concept of private cloud. So this is a typical example which is mostly used by government organizations where they don't want to share even their hardware. So what happens is that if you create the same SQL database in a private cloud, then you essentially own the hardware. I won't say own. It's something like it won't be shared across multiple vendors. So it will be exclusive to you. That is the concept of a private cloud. Then we have the hybrid cloud. So in the hybrid cloud, what happens is some of your infrastructure will be on premises, that will be within your network, and some of the infrastructure will be on the cloud space. This is a concept of hybrid cloud. So these are the three different technologies or the design choice that we have in a cloud environment. Now, another important aspect in cloud is the technology or the tools itself, how they are created. So when you work in cloud computing, you'll hear these three terms very often: infrastructure as a service, platform as a service, and software as a service. So these are the three essential categories on which we create any resource in a cloud factory. How it happens is that if you think about platform as a service, which is the most common thing that we have, when I say most common, is that something that is very popular where people create so many PaaS resources or platform as a service. What does this mean is that when you create any resource in Azure or any other CSP, you don't need to bother about the underlying hardware how the hardware is managed, how the connectivity is set up. Obviously you have to set up the networking, but the hardware is completely managed by the CSP. Then the software upgradation, the patching, all these things are also managed by the CSP. So again, if I think of an example of SQL database, if you create an Azure SQL database, which is a PaaS offering, I can quickly spin up my SQL database. I can set up the configuration. I can give the details, how many cores we want, memory we want to consume, how much IOPS we need, and we can quickly set it up. Microsoft, being a CSP for Azure, they have an SLA that you will get this much of minimum performance, this much of uptime. All these things are part of Microsoft's SLA. Also, the upgradation and the scheduling and the patching is done by Microsoft. It's taken care by them. You don't have to bother about these things. That's the concept of PaaS, or platform as a service. Then we have infrastructure as a service, or we call it as IaaS. What happens in this case is, here you want to work in a cloud environment, but you want to manage your own infrastructure. So a typical example would be a virtual machine. So if you create an Azure virtual machine, there you manage your operating system, you manage your software. So for an example, you create a Windows virtual machine. Inside you install SQL Server. So Microsoft will give you an image of a virtual machine along with SQL Server installed, but you are responsible for the OS upgradation, the SQL Server upgradation, the patching. All these things are done by you. This is an example of infrastructure as a service. And then finally, you have software as a service, where some people will also call it as a serverless architecture. What happens in this case is, you're utilizing the power of cloud, but the software that you're using, it's actually coming as a product. So a simple example would be Office 365, or now Microsoft has renamed it to Microsoft 365, where your underlying server, where the mail exchange is happening, that's happening from a cloud perspective, but you're actually using that product to create your own set of products. So this is a very high level concept of cloud computing. How do we work with cloud, and what are the different concepts we should keep in mind before we start our journey in cloud? From a work perspective, it's very simple. You just log into the Azure portal. So this is a simple example. I've opened the Azure portal. So this is how it typically looks like. You log into portal.azure.com. I'm not going to go through so many hands-on today because it's the first session. Just wanted to give you a physical overview. You have to create your subscription, and then you can get started. Now, people who don't have an Azure subscription, like for an example, I have a Microsoft Developer Network subscription. So people who don't have a subscription, Microsoft gives you a 30-day free subscription for Azure, and you get $200 of credit, and you can create your resources inside the Azure portal. So you can just create a free subscription with your email ID. You get $200 of credit, and you can start your journey in that. I'll definitely share some of the tips with you to save money so that you don't exhaust your $200. Otherwise, it will be difficult. You cannot work. If I'm not wrong, just a quick tip. Microsoft do asks for a credit card information. That's just for verification. They will not charge you. If you exhaust your $200, they will not charge you extra. You will receive an email that your subscription has been disabled. If you want, you can pay and you can restart your services. So don't worry about the credit card information. You can keep it, you can save it. They will not charge you from your credit card. So that's a very quick overview of cloud computing and the Azure portal. Now we will dig deep into the data engineering role and how Microsoft has stacked up the data engineering portfolio in Azure. Now, before I do that, I'll take a quick pause to check with all of you. Do you have any questions till now?
No.
Seems like no questions. Thank you. So let's get introduced into the data engineering world. Now, since we are talking about data engineering, of course, the core of data engineering is data. Now, it's no secret that the data that we use and we consume has been growing more and more in size. So it's a very old cliched line, is that all data is the new oil. So I'm not going to go through all the things. We all understand the importance of data now. So what's happening is nowadays, whenever we're looking into the world and we're seeing the projects, we're doing the work, we see that the data volume is increasing significantly. Now, since the data volume is increasing significantly, we have to use some kind of new technologies. We cannot use the traditional mechanism of dealing with data because we are not getting the performance that we expect, and we are not getting the outcome that we require. So with the increase of new data and the increase of data, we are seeing a lot of new technologies, new roles, and new approaches which are being affected by the data professionals. Okay,